So in this class, I will explain about the strain displacement relations in polar coordinates. So you know that coordinate systems, we have three types of coordinate systems: Cartesian coordinate system, where x, y, z are used; cylindrical coordinate system, where r, theta, z are used; and spherical coordinate system, where r, theta, phi are used. But in elasticity, normally we come across with two-dimensional Cartesian, that is using x and y, three-dimensional Cartesian, x, y, z, then polar coordinates r and theta, because most of the problems we can have convert into axisymmetric problems wherein the member will be symmetrical about z axis and therefore only r and theta are enough. So two-dimensional cylindrical coordinate system is known as polar coordinates where only r and theta are used. So you know the relationship between x and y, r and theta, all those I have explained in the earlier video where r square is x square plus y square and tan theta is y by x. That is the transformation from Cartesian to polar coordinates. So in the case of polar coordinate, that is only we are using r and theta, one linear and one angular. So r means it is in the radial direction, whereas theta is in the angular direction. So like this, so this is x axis, this is y axis. If you take a point P here, this point P can be in Cartesian coordinates, it can be x comma y. So if this is r and this is theta, then definitely you can say that r square is x square plus y square and tan theta is y by x. So this is the relationship between the Cartesian and polar coordinates. This is the relationship. So by knowing one linear and one angular measurement, you can always locate a point. So in the plane. So this is a planar problem because it is two-dimensional. So polar coordinates is nothing but two-dimensional Cartesian coordinates. So in this case, you will be having three strain components: epsilon r, epsilon theta, and gamma r theta. Where epsilon r is called as a radial strain, which acts in the radial direction. If O is the center, it acts in the radial direction. And circumferential strain is epsilon theta, which acts in the tangential direction. So please note that this epsilon theta and epsilon r, they are mutually perpendicular to each other because radius is perpendicular to tangent. So it will be acting along the tangential direction, that is epsilon theta. That is why it is called as circumferential strain. Then you have, or you can also call it as tangential strain also. Tangential strain because it acts along the tangent like this. And the third one is the shear strain, which acts in the plane. So this is how we can represent epsilon r, epsilon theta and gamma r theta in a planar element. This is the element you can have in polar coordinates. And epsilon r will be acting along the radial direction, epsilon theta will be acting along the tangential or circumferential direction, gamma r theta is the shear strain which acts along the in the r theta plane. Now these are the expressions for the strains in terms of displacements. So here also we are going to take u and v as the displacement components along x and y directions like this. So in this case u and v, they are functions of r and theta. In Cartesian coordinates they are functions of x, y, z. Here in polar coordinates u and v, they will be functions of r and theta, because at each point you will be having different values of r and theta, and displacements will be different when the element is subjected to external forces. Now here epsilon r, which is the radial strain, is given by dou u by dou r. All this can be proved, dou u by dou r. Epsilon theta is u by r plus 1 by r into dou v by dou theta, and gamma r theta is dou v by dou r plus 1 by r into dou u by dou theta minus v by r. So these expressions, these equations, they are called the strain displacement relations in polar coordinates. So for three, because we will be having three strain components in polar coordinates, so three expressions will be there. So these three you have to remember. If the problem is given, you should remember these three formulae to evaluate these strain components. Now let me take a problem on that. determine the strain components, that means these three, epsilon r, epsilon theta and gamma theta, at the point minus pi comma pi by 3. That means this minus pi is nothing but r, pi by 3 is nothing but theta. Pi by 3 means it is 180 by 3, that is 60 degrees. So at that point you have to evaluate the strain components because strain varies from point to point. So these two are the functions they have given. U and V, they are functions of r and theta as already told. U is pi r square sin 2 theta minus r theta cube and V is and V is 10 r cube cos 2 theta minus r square theta. So this is what is U and V are given. So if you differentiate this with respect to r and theta, you are partially you are going to get dou u by dou r, dou u by dou theta, dou v by dou r and dou v by dou theta. So those things we can easily get. Now let us see how we can evaluate the strain components. To evaluate the strain components, we need to find the derivatives. So of these two with respect to r and theta. So first I will find out the derivative dou u by dou r. So dou u by dou r, when you are differentiating with respect to r, so what happens? You have to treat theta as constant. Please note that partial differentiation dou u by dou r I will do first. When you are differentiating this u with respect to r partially, theta is taken as constant. So I will take here this r square, if you differentiate it becomes 2r, 2 into 5 is 10, 10 r sin 2 theta minus differentiation of this will be theta cube, if you differentiate with respect to r. Now at this point, so I need at the point minus pi comma pi by 3, that means r is equal to minus pi, theta is equal to pi by 3. Let us calculate this value. So 10 into minus 5 into sine 2 pi by 3 minus theta cube, that is pi by 3 cube. So here pi by 3 is in radians. So when you are using this, you have to keep the calculator in the radian mode. So that is very important. Now let me simplify this. So minus 50, so it becomes minus 50 into sine of 2 pi by 3. 2 pi by 3 is 120 degrees. Minus pi by 3 whole cube. Pi by 3 whole cube. So the value you are going to get is we should be very careful here. Your calculator should be in the radian mode. So you have to convert your calculator into radian mode. Then only you have to do the problem. So if you convert that into radian mode and do, so you will be getting this value as minus 44.45. Minus 44.45. That is the value of dou u by dou r. Next, you can find out this dou u by dou r itself is your epsilon r. So epsilon r directly is equal to this. Now this is the first strain component. Second strain component is epsilon theta, which is given by u by r plus 1 by r into dou v by dou theta. So let us find out this derivative first. U by r, u is this. If you divide this by r, you will get 5r sin 2 theta, 5r sin 2 theta minus theta cube. This is the first term. Plus dou v by dou theta into 1 by r. So 1 by r will be there into dou v by dou theta. So this we have to differentiate with respect to theta now, treating r as constant. So 10r cube becomes constant into the derivative of cos 2 theta is minus sin 2 theta divided by 2. So into into 2. That means it becomes minus 2 sin 2 theta. So you should be knowing the derivatives. That is very important. Without knowing that, you cannot do this. Then derivative of this will be, you are differentiating with respect to theta, so it becomes 2 theta. So that means minus 2 r square theta. Yeah, this is what we get. So if you simplify this, 5r sin 2 theta minus theta cube. So I have to divide this entire thing by r. If you divide that, plus into minus is minus, this becomes 20 r square sin 2 theta. And this becomes minus r and r will get cancelled, 2r theta will be there. So this is what you are going to get. Now put the value of r as minus 5 and theta as pi by 3 here, and see the calculator in the radian mode. So this is r is minus 5 into sine 2 pi by 3 minus pi by 3 cube minus 20 into pi square, minus pi square of course, into sine 2 pi by 3 minus 2 into minus 5 into pi by 3. So this is the simplification. If you use the calculator and if you simplify this using radian mode, the value of circumferential strain or epsilon theta is minus 445.34. Please check the answer. Please check the answer. This is the answer you are getting. This is second strain component. Now this third strain component, that is the shear strain component. So that is gamma r theta. So write down the formula in third one. Gamma r theta is equal to dou v by dou r. Write down the formula. Dou v by dou r plus 1 by r into dou u by dou theta. Dou u by dou theta minus v by r. So substitute now first here we have to differentiate this v with respect to r, treating theta constant. This becomes 3 into 10, that is 30 r square cos 2 theta. It becomes 30 r square cos 2 theta minus, so dou v by dou r means it is 2r theta square. 2r theta square plus 1 by r into dou u by dou theta. This we have to differentiate with respect to theta, treating r constant. So it becomes 5r square into 5r square is constant into, so derivative of sin 2 theta is 2 into cos 2 theta. 2 into cos 2 theta minus derivative of r theta cube with respect to theta is 3r theta square minus 3r theta square. So this is what you will have for this second term. Minus v by r, minus v is this, we have to divide this by r, 10r square cos 2 theta minus r theta square. So this is what we get. So now in this we have to, of course, still we can simplify this. 30 r square cos 2 theta minus 2r theta square plus this divided by r will be 5 times 5 into 2 10 r cos 2 theta minus 3 theta square. This is minus 10 r square cos 2 theta plus r theta square. So still we can simplify this. You can see here these two we can combine, 30 r square theta, 10 r square cos 2 theta. It becomes 20 r square cos 2 theta plus 10 r cos 2 theta, and this and this if you combine minus r theta square, and this is minus 3 theta square. Now in this we have to substitute for r and theta. R is minus 5, theta is pi by 3. So 20 into minus pi square into cos 2 pi by 3, theta is pi by 3 here, plus 10 into minus 5 into cos 2 pi by 3 minus 5 into pi by 3 square minus theta 3 into theta is pi by 3 square. So this is what you get. So I have the calculator in the radian mode and substitute and simplify. You will get the answer for this as minus 222.56. Please take the answer. So this is the shear strain. So tangential strain is minus 445.34. This radial strain is minus 44.45 and shear strain is minus 222.56. So like this, you can, if you want to plot the, suppose this is the point 5 comma minus 5 comma 5 by 3. So you can suppose if this is the element, just I approximately I will show how to plot the values. So epsilon r, that is the radial strain, you have got negative. Negative normally it indicates compressive strain like this. So this is the strain direction, compression, epsilon r, and epsilon theta. Of course, that is also negative. So anti-clockwise negative, clockwise positive you take. So the strain in this direction. So in this, this is epsilon theta, radial rather than tangential, and this is epsilon r. So you can take this clockwise, this thing as negative. At this point, I am talking about at this point. The value of epsilon theta is this much. At this point, the value of epsilon r is this much. And gamma r theta, of course, the shear strain, we have got negative value. So that also I can show approximately like this. So this gamma r theta will be there. I can show in this fashion like this. So this is the gamma r theta value. So anyway, three components. You need not sketch that. The values are important. These are the strain values which we are going to get at that particular point, and the value of strain varies from point to point because r and theta will be different at different points. So this is how we can find out the strains given the displacements in polar coordinate system. So only thing is we should be knowing these three relationships. So these three relationships are called as strain, displacement. U and V are the displacements. Epsilon or epsilon theta, gamma theta are the strains. So strain displacement relations. One, please note that one is linear measurement, that is r along the radial direction. Another is the angular measurement, that is along the circumferential direction or the tangential direction.